Alrighty, this is 3.3, day 3, the second page of it. If you haven't yet, you should take a moment and try and do the partner practice on your own. All right, so do this on your own if you haven't tried it yet, and pause the video. Okay, hopefully you come back, press play so you kind of see the answer. So, what translates the graph vertically, moves it up or down? That is the K. Right, that moves the vertex, moves the whole graph up and down. Affects the parabola shape. What we mean by that is if it's skinnier or fatter, or there's a compression or stretch. So that is all about the A there. The line of symmetry falls through, right? If here's my parabola, the line of symmetry goes through my vertex, and it's the x coordinate, so it actually is the H here. This is also, it moves the graph horizontally, left and right, as well as what represents the maximum and minimum value. So again, the maximum and minimum occurs at the vertex. So we would say x is the where and y is the value. So when it asks represents the maximum or minimum value, that would be the y value in it, which is my k. And then what determines if it has a maximum or a minimum? Well, if it's pointed down, it has a max. If it's pointed up, it has a min. So what determines if it's a max or a min? Well, that determines if it opens up or down. So that determines by A. So that's partner practice. Part 2, use the discriminant to determine the number of x-intercepts for each of the following. We haven't talked too much about this. The discriminant, if you don't remember, the discriminant is the inside part of the square root during the quadratic. So our quadratic formula is opposite b plus or minus the square root of b squared minus 4ac all over 2a. So the discriminant specifically is b squared minus 4ac. Now the nice thing about this, it can tell you how many x-intercepts there are. So let's go through these and kind of see what happens. If I were to evaluate this, we'd get 4 squared minus 4 times negative 1 times negative 2. Okay. That equals 16. Negative 4 times negative 1 is 4, times negative 2 is negative 8. That equals 8. Okay. Since this number is positive and bigger than 0, there are 2 x-intercepts. Okay. Try and fit b in here. If I do this discriminant now, that's 2 squared minus 4 times 1 times 5. So 2 squared is 4 minus 4 times 5 is minus 20. This equals negative 16. This is going to have no x-intercepts. The reason for that is you can't take the square root of a negative number, and that is, so this is never going to touch the x-axis. All right. And then lastly, here we go, we're going to have negative 4 squared minus 4 times 1 times 4. Negative 4 squared is 16 minus 16. That equals 0. If it equals 0, there's one x-intercept. All right. All right. So maybe I'll just write that down here again. If the discriminant, which is b squared minus 4ac, we'll call that d. We'll just say the discriminant. If the discriminant is bigger than 0, 2 x-intercepts. If d is equal to 0, that's a bad one, 1 x-intercept. And if d is less than 0, no x-intercepts. Okay, finish this up here. Okay, these are a little tougher. We're going to write the equation of the x-intercept. Okay, So the easiest way, I think, is depending on what the information you have. Here we have a vertex. We're given the vertex is -3, -5. So I would jump right into vertex form. Recall, though, vertex form is a x minus h squared plus k. So I'm going to have y equals a x plus 3 squared minus 5. Like I go the opposite inside there. Now, this is what most people forget. A lot of people forget this on the test every year. You need the A out in front because that tells you how skinny or how wide the graph is. Okay, and the way to determine that is this point right here, 0, 4. You can find any point on the graph, but we're going to take 0, 4, and we're going to sub it in to solve for A. Okay, so we're going to get 4 equals A, 0 plus 3 squared minus 5. If I simplify this, actually, I'm going to write it. So that would be, I'm going to subtract, or I'm going to add my 5 over. So I'm going to get 9 equals A. 0 plus 3 is 3 squared. So this is 9A times 9 divided by 9. A equals 1. So it turns out my parabola, the equation of this is just 1x plus 3 squared minus 5. Yeah. Now, we do the same thing again for 2. Now, we can obviously tell A is not going to be 1. There's a clear indicator for why it's not 1, and that's because it's pointed down. So there's got to be some multiplication going on in front to flip it down. But again, we got a vertex, so I say let's start there. We'll go y equals A x minus y equals A x minus h. Sorry, I know what my h is. My h is 4. X minus 4 squared plus 6. Okay. Now, we just need to find another point. They're telling you that there's this point 8 comma negative 2. So I can sub that in right away. So negative 2 equals A x minus 4 squared plus 6. Subtract the 6 over. Negative 8 equals A. 8 minus 4 is 4 squared. Then I square that. 4 squared is 16, so this is A times 16. So I divide these by 16. A equals negative a half. So my final equation is y equals negative 1/2 x minus 4 squared plus 6. 3, 4, and 5 are the exact same, except instead of looking at a graph, they give you the information. So try 3 or 4 on your own, and I'll give you the answers here in a second. Okay, here we go. So my vertex, again, I'm going to start in vertex form. Y equals A x minus 4 squared minus 5. Now I'm going to just put that point inside. So negative 1 equals A 2 minus 4 squared minus 5. Add my 5 over to the other side, so I get 4 is equal to A minus 2 squared. So I added my 5 over, and I combined the inside. I can now multiply, or I could square that. So 4 equals A. Negative 2 squared is 4. So my A is actually just 1 here, so it didn't change. So my equation is just y equals 1 x minus 4 squared minus 5. Here we go. Number 4, if you did that one instead, y equals A x plus 3 squared plus 1. I'm going to go ahead and put this point in. So negative 8 equals A 0 plus 3 squared plus 1. Negative 8 equals A 3 squared plus 1. I'll move that 1 over now. I didn't know I didn't do it before. Negative 9 A times 9. 3 squared is 9. So, here we go. A equals negative 1. So my final equation is y equals negative 1, x plus 3 squared plus 1. And last one, like I said, find the ones, use the information that they give you. Number 5 gives me my x-intercepts, not my vertex now. So I'm not going to do vertex form. I am going to do factored form, which if we remember is y equals a, x minus, I called it p, x minus q. Realistically, this means get your factors. Okay. So if I have my x-intercepts of negative 2 and 5, that means x equals negative 2 and x equals 5. So to get my factors, this is x plus 2, right? X plus 2 equals 0. X minus 5 equals 0. I'm kind of going backwards in the factoring process. So we'd have 0 equals x plus 2, x minus 5. So those are my factors, okay? So for my general equation, I have y equals, I don't know my a yet, so a equals x plus 2, x minus 5. Okay. From there, I can now put in my extra point to get out what a equals. So my y is 2. 2 equals a times 6 plus 2, 6 minus 5. So 2 equals a times 8 times 1. 2 equals 8a. A equals 1/4. So my final answer here would be y equals 1/4 x plus 2, x minus 5. And there we go. Right? If you want to check any of these, making sure we did it correctly, or if you're at home and trying to do your homework and want to check if we did it correctly, Desmos would be a great opportunity. Put your equation into Desmos, and then you can see, hey, did I actually find those points? And we could do that for this one real quick for you all. So here into Desmos. So we got y equals 1/4 x minus 2, x plus 2, x minus 5. So as I see here, boom, I have an x-intercept at negative 2 and an x-intercept at 5. Those were the two things that were important. And then 6 comma 2. So I'm going to go, ooh, not that. Look at 6, when I write on this graph, I get to 6 comma 2. So it does work. So that point is on my graph. So I had the correct A. Notice here, let's say we didn't have the correct A. Let's say we just left it at 1. We still have our x-intercepts, which are true. However, at 6, our value would be I'd be at 6 comma 8, but not 6 comma 2 like they wanted me to. So I needed a vertical compression to bring that graph down. All right, so there you have it.